Okay, today we're in section 2.3, converting between fractions and decimals. We're going to go both ways, a fraction to a decimal and a decimal to a fraction. The first thing we need to do is just clear up some important information here. We have a terminating decimal. It's a decimal that ends, okay? So it's 2.25, 4.214, but the decimal value stops. Okay, there's a clear stopping point. And then a repeating decimal has a pattern. That's really important. It has a pattern that repeats. Okay, so we see three examples, and we just need to identify if it's a terminating or a repeating decimal. A really clear and obvious marker that we look for is that bar notation. Bar notation, the bar above the numbers. Okay, the bar notation would tell us if it's a repeating decimal very clearly. So on number 1, everyone together, what kind of a decimal value is that? Terminating. Let's just write a T. What about number 2? Repeating. And number 3. All right, so we're just kind of rehearsing and refreshing our memory on the difference between a repeating decimal and a terminating decimal. All right, now because we haven't really worked through equations yet, there is one conversion that we are not going to do today, and that is a conversion from a repeating decimal to a fraction. Okay, and you might think that might be as kind of simplified as the other conversions, but it's not. So we're not going to look at that one until later in the semester. All right, so that's why the terms talk specifically, between terminating and repeating. You'll see that in the examples. Okay, so on example 1, we are writing fractions and mixed numbers as decimals. Now, I'm going to kind of start off by saying this. On your quiz and your test, if I give you a fraction value, that you have the decimal value memorized. For example, if I said 1/2, convert 1/2 to a decimal. Do you need to do any long division to convert that? What's the decimal value? 0.5, okay? So if you have it memorized, that is okay. Because you don't have your calculators, I understand that you know that, all right? And on an SAT or ACT test, the same would apply, okay? So memorization is definitely a good thing. If you don't have a value memorized, like say we're about to convert 3/8, that might be one that you know. And if you don't know it, once we convert it once, guess what? You could memorize that. And then you would not have to do the work next time. See how that could maybe help you? All right. So I'm going to do the long division just to show you if you are unsure of how it converts. This is the method we can use. If you already know what it is, that's awesome. That's great. You do not have to show the work. Are we clear on that? Okay. So here we go. -2 1/4, we're still going to stick by what we say about converting mixed numbers to improper fractions. This will convert to -9/4. We know when we're dividing fractions, the numerator goes on the inside and the denominator goes on the outside. Okay? Does 4 go into 9? 2 times. But not evenly when we subtract. So what do we have to put after the 9? A 0. And bring it down. 4 goes into 10 how many times? 2. And 2 times 4 is 8. Subtracted, I have 2. I need one more 0. And 4 goes into 20 how many times? Okay, so my answer is 225, right? No. What did I forget? Bring that decimal up into your quotient, and your answer is 2.25. Now, going back to what I said at the beginning of the lesson, guys, how many of you, don't necessarily raise your hand, but just kind of nod, knew that 1/4, the decimal value was 0.25? Did you guys know that? Okay, so that's awesome. If you knew that, you could have just gone straight to your answer, -2.25. Okay, and that is okay with me. But because for the purpose of the lesson, I'm going to show you the long division. All right, if you know the value, then that's great. You can take a shortcut on that problem. All right, let's do 5/11s. We're gonna work across. Let's do 5/11s. Same process. 5 goes on the inside. 11 goes on the outside. Does 11 go into 5? No. So 0. And then I put in my decimal, bring it up into my quotient. Does 11 go into 50?
Yes.
How many times? All right, and the process begins. 50 minus 44. Left over, so add my 0. 11 goes into 60. 5 times. All right, I want you to continue the multiplication. All right, continue working through this. All right, so I bring down another 0. 11 goes into 54 times. All right, that's going to be 44. I have a pretty strong indicator at this point that what kind of an answer do I have? A repeating decimal. As soon as I see that those digits repeat once, I can go ahead and stop. And I can say that my answer is 0.45 repeating, and I'm done. Okay, 0.45 repeating. Any questions on that? All right, guys, so the second two, these two on the bottom, are exactly the same thing. Okay, it's exactly the same thing. Because we need to do some review time at the end for our quiz review, we're going to go ahead and move on to the next example. All right, okay, so just a fraction to a decimal, we do the long division. Okay, and hopefully we'll have some time to start on homework at the end, and I can help you a little more. All right, so in example 2, we are going to do all of these in example 2 because they're all a little bit different from each other. In example 2, to change a decimal to a fraction, I need to look at the place value of the last digit in my decimal value. All right, so the 6 is in what place value? The 6 is in what place value? The hundreds. So whatever value you say, that number goes in the denominator, 100. Okay? Then the actual decimal value goes in the numerator. Okay? Negative 26 over 100. And then I can reduce the fraction anytime it's possible. I need to reduce the fraction. So 26 over 100, I can reduce by what factor? 2 to make negative 13 over 50. All right, so going from a decimal to a fraction, I'm looking at the place value of the last decimal. All right, so based on what I just said, I want you to try to put this next one, we're going down this time, so 0.125, put that into a fraction and try to reduce it. I'm going to take a quick walk around to check on you guys and see how you're doing. All right, what place value is the 5 in? The thousands. Walking around, I could see that some of you had this memorized. That's okay. Like I said at the beginning of the lesson, that's fine. All right, but if you don't have it memorized, you need a fallback. Okay, this is your fallback. What is the last place value? It's the thousandths place. So that's what goes in my denominator. And the 125 goes in my numerator. Now, there's a couple numbers that this can be reduced by. If you can come up with the biggest one, you only have to reduce it once. Matthew? No, it doesn't go into 125 evenly. Joel?
125.
Okay, you are right. 125 is divisible by 1,000. Now, the common answer I got, I'm going to scale it back. He did find the GCF. That's awesome. What if we reduced it by 25? Okay, that was the common answer last hour. Anybody else reduce it by 25? Okay, that's great. And if you reduced it by 5, you should still get to the right answer also. So if we go 25, we would get 5 over 40. Okay, if we reduce top and bottom by 25, and then I could reduce that one more time and get 1/8. That's fine. All right, if you don't find the GCF to start with, just keep reducing until it's all the way reduced. All right, did you guys get 1/8, or were you on your way to getting that answer? All right, negative 10.25. Anytime we see this whole number out here, how do you think that's going to be written as a fraction? Anybody have any ideas? Caleb? It's going to be written as a whole number, right? And we call that a what kind? Mixed number. Okay, so negative 10 All right, and we've talked about this. Do we remember what 0.25 stands for? You guys remember that? What is it? Just tell me. 1/4. Now, if you forgot, you would say 25 over 100 and then reduce it. Okay, but if you remember, you can just put it off to start. Okay? How would I read this place value at the 0.3? How do I read that place value? What goes in the denominator? 10. What goes in the numerator? 3, and then negative. And there's nothing we need to do. That's just -3/10. Okay, questions? All right, so let's pull it all together. Whether it's converting a fraction or converting a decimal. Now in example 3, it wants us to make a comparison. Okay, I think we've talked about this briefly already, that we cannot, all right, so if you don't remember, or if we didn't talk about it, here we go. You cannot compare values that are in basically different units, like a fraction and a decimal. That's not a good idea. You need everything to be the same. So you have a decision to make. You can make them all decimals, or you can make them all fractions. Okay? So because of where we are with this and the fact that we may have some repeating decimals that we're dealing with, we are going to convert fractions to decimals. We're all going in that direction. So if you're making a comparison, which way are you going? Fractions to decimals. Everything needs to be a decimal. So in this chart, which one do we not have to really touch yet? The whale. The whale is already a decimal. I need to change the other 3 to decimals. Okay, go ahead and make those conversions. Okay, and we do that by dividing numerator and denominator. Okay, all right, let's go ahead and convert anglerfish, shark, and squid to decimals. Then we can compare and answer the question. Okay, so on number 1, 13 divided by 10. So the 13 goes inside, 10 goes on the outside, 10 goes into 13 once, with 3 left over, so I need a decimal. Bring down my 0, 10 goes into 30, 3 times, 1.3. Did everybody get 1.3? Negative 1.3. Okay, now on the next one, 2 and 11. This one's going to take the most time. Okay, 11 does not go into 2. 11 does go into 20. How many times? 1 with 9 left over. Bring down the 0. 11 goes into 90. How many times? 8. Okay, this is my first hint that I might have a pattern going on here. 11 goes into 20. How many times? Once. Okay, 11 with how many left over? 9, and I bring it down. 90 and 8 times. So I see the 18 repeating. So I do know that -2 11ths is 0.18 repeating. Okay, now the squid, -2 1/2. All right, that would be 11 divided by 5 as an improper fraction. 5 goes into 11 2 times. 10, 1, decimal point, bring it down, and I know that it's 2.2. I did see, walking around, I did see that some of you only divided the fraction and then you just put the 2 in the 1's place. Did anybody do that? That is okay. That's okay. All right, you're not wrong doing that. It's just if you change it to a mixed number and you have your whole answer together, I've seen fewer mistakes made that way. So that's why I teach it that way. Okay? But either way is fine. -2.2. Now I'm ready to compare them. And I'm going to compare them by listing what the animal is. Okay? Not necessarily the values. All right? That's this whole real life application. So let's go back to the question. Which of the sea creatures are deeper than the whale? So don't just tell me a number. A number does not answer that question. Okay? Again, the whale was already a decimal. So now that I have the rest of them in decimal values, can you answer that question for me? Anybody answer it for me, Jack? The shark, no, because remember, okay, so this is a good point. With the negative, the farther it is from zero, the deeper it is. So if you're negative 10 feet down and somebody else is negative 20, they're deeper. They're deeper, okay? So I know that's like, Hadley? Okay, the squid, very good. The squid is probably the deepest, right? Is there any others that are deeper, Samuel? And the anglerfish. All right, so here's the sad part. Because of the question that it asked us, if you gave me the numbers, that's not the correct answer. You say, but the squid was negative 2.2. That's what I said, but you didn't answer the question. Does that make sense? It said which fish. Negative 2.2 is not a fish. Okay, so you have to actually answer the question. All right, so that's it for 2.3. I'm going to stop the recording here, and we're going to switch gears to our quiz review. All right, the purpose of the quiz review is to warm you up to the types of questions you're going to see on Monday. So we're going to move quickly through this so we can get through it all, okay? So it's more just kind of some more notes and working through problems.